Hey guys, let's see how we can solve question 2 from the chapter 8 of beer&johnston textbook Engineering Mechanics. And in this one, we need to determine whether the block shown is in equilibrium or is actually moving. And at the end, we need to find the magnitude and the direction of the friction when we have our theta 30 degrees and the force P 150 newtons. So we're going to start with assumption of equilibrium. So we're going to assume that we are in equilibrium. And if that's the case, sum of all forces is equal to 0. And since we are in 2D, we have one equation for x and one for y. Let's call our x and y before we start. So we call this our x, and this will be our y-axis. So in the question, we know our theta is 30 degrees, and this angle right here would be also 30 degrees since we have these two parallel. So if we have these two and this one, these two will be the same. And if that's the case, the angle right here between 1.2 kilonewton force and our y-axis would be also 30 degrees. We have static coefficient and kinetic coefficient for this question. And let's start with our equilibrium assumption, and we can do sum of all forces in x equals 0. Let's see what we have in x. But we have to consider one friction for now. And if you want to draw the free body diagram, so we basically have, so this will be our force P. We have the 1.2 kilonewtons or 1200 newtons force. And the other force that we have is friction. We don't know what is the direction of friction, so let's just assume for now that this is our friction. And we also have a normal force applying on the surface. We're going to call it N, and that's pretty much all the forces that we have in here. So this angle here would be 30 degrees, and also the angle between our y and 1200 is also 30 degrees. So that's pretty much all the forces that we have. Now we can do sum of all forces in x. So for x, we have F acting on positive x-axis. We have the x component of P, which is what we have in here. So minus P cosine of 30 degrees. And we have the x component of the 1200, which is what I showed in here. So that one's positive plus 1200 sine of 30 equals 0. So the F in here would be, if we bring these two on the other side, we have P cosine of 30 degrees or 150 cosine of 30 degrees minus 1200 sine of 30 degrees. Sine of 30 degrees is 0.5, so 1200 divided by 2 is 600. So we basically have 150 cosine of 30 minus 600. That's going to be minus 470.1 kilonewton, and the negative sign in here shows that our F was actually in the opposite way, so our F is in this direction. So that's the correct direction for F, which means the box is either in equilibrium or it's going down the hill. But to confirm that, we have to find the maximum of friction in here, and for that we have the static coefficient, which is greater than kinetic coefficient, and therefore it makes higher friction. So the max would be the static coefficient times n, or the normal forcing here, but we have to figure it out. And we have one more equation, sum of all forces in y equals 0. So we're gonna have n minus p sine of 30 degrees. Again, our p is 150 minus 1200. So this was our y component. This will be the y component for 1200 cosine of 30 degrees equals 0. We can find n. Again, we know sine of 30 is 0.5, so 75 plus 1200 cosine of 30 degrees. Let's see what we get. 75 plus 1200 cosine of 30. It's going to be 1114.2 kilonewtons. That would be our n. So now that we have n, we can find our friction in the previous step here. The coefficient would be 0.35 times 114.2. Let's see what we get times 114.2 times 0.35. It's going to be 389 or almost 390 kilonewtons. And now if we compare our F with the maximum friction, we can see that our F is greater than the maximum friction, which means the box is actually moving. And if the box is moving, the force that we have for friction would be different, because in that case, we are not in equilibrium, so sum of all forces is not equal to 0. It's actually mass times acceleration, but we don't have any information for these two. And we know that friction would be kinetic coefficient times n, and we have the kinetic coefficient in the question. It's 0.25 in here, so 0.25 times our n. What we have in here were 114.2. Let's see what we get. 1114.2 times 0.25. That's going to be 278.6 kilonewtons. And that shows that the box is moving down. So the block moves down. And if we get back to the question one more time, we have to find the magnitude as well as the direction. So the final answer would be 278.6 kilonewtons. And we figure out the direction is actually in this, since we got a negative sign. So since we got a negative sign for friction, that shows that our assumption at the beginning was not correct. And this is actually the correct direction. So this will be the F, and the angle in here would be the 30 degrees that we have. So just going to show that in here. So 30 degrees, and this is going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. And you guys take care. I'll see you in the next one.